Okay, we're in section 9.3 now, and I was going to do some more of that. We had left off with problem 18. We already did parts A and B here in the last video, so I was going to pick it up with part C. Now we're simplifying, and then also assume that all the variables represent non-negative numbers. Okay, now I mentioned in the last video, a lot of what we're doing here is we're going to be organizing things into groups. In the case of a square root, it's going to be things that you know the square root of, and then things that you don't know the square root of, or think of that other group as like the leftover there. Okay. So let's take a look at part C. I'm going to split this radical into two radicals, and underneath the first one I need to know, it'd be things that I know the square root of. So 175 is the same as 25 times 7, and I know the square root of 25 is 5. The square root of 7, well, that doesn't break down further, okay, and that's also not a whole number value, so I'd put the 7 in the leftover part. X to the 11th, that's the same as x to the 10th times x. And in the case of a square root, okay, I'd want anything with powers to be even numbers. X to the 10th, that's the same as x to the 5th squared. Right? And that's what I'm doing in the next line. I'm rewriting this as the square root of something squared. Okay. Y to the 5th, that's the same as y to the 4th times y. And z to the 23rd, that's the same as z to the 22nd times z. Now, like I said, I'm going to be rewriting this first radical, this one here, into a form that is the square root of a squared expression, because then the radical and the power of 2 can go away. Let's see here, 5 squared is 25. X to the 5th squared, that'd be x to the 10th. Y squared squared is y to the 4th. Z to the 11th squared, that'd be z to the 22nd. The square root of 7xy, that's the leftover. None of that breaks down any further. Okay. Now the square root is going to cancel with the power of 2 there, and just leave me with 5x to the 5th y squared z to the 11th times the leftover. That was the square root of 7xyz. Okay, and you'd circle that there. Okay, part D. The cubed root of 16x cubed y to the 4th z squared. Okay, let's go ahead and split that into two radicals, things that we know the cubed root of and then the leftover. With 16, okay, let's see, if we use 8 times 2, I know the cubed root of 8, that's 2. This 2 here would be my leftover. X cubed, well, the cubed root of x cubed, that's x, so that x cubed can stay under the first radical. I don't have any leftover from the x terms. Y to the 4th, that's the same as y cubed times y. The cubed root of y cubed is y. And z squared, I'm going to have to put the z squared entirely in the second radical since the power there is less than the index. The cubed root of 8 is 2, I mentioned. The cubed root of x cubed is x. The cubed root of y cubed is y. So we got 2xy times the cubed root of 2y is z squared. That'd be my answer to that one. Okay, here's another one. We're going to break down a fifth root. Okay, so things that we know the fifth root of and then the leftover. Now the fact that this is a fifth root means that the powers of the terms underneath the first radical need to be multiples of 5. Right, because the fifth root of something to the 5th power means that that index and that power of 5 will go away. Well, 30 is a multiple of 5, right? So a to the 33rd, that's same as a to the 30th times a cubed. B to the 6th, that's same as b to the 5th times b. C to the 50, well, 50 is already a multiple of 5, right? Now, a to the 6th to the 5th is a to the 30th. So the fifth root of a to the 6th to the 5th would be a to the 6th. The fifth root of b to the 5th, that's b. And the fifth root of c to the 10th would be, c to the 50th, that'd be c to the 10th. Since c to the 50, that's the same as c to the 10th to the 5th. Okay, and this guy here would be, I just rewrite that again, that's my leftover. Okay, here's another one. We're dividing now, so I'll start by splitting this into two radicals, and then I want to split further into two groups, things that I know the square root of and then the leftover. In the case of 44, I know that 4 times 11 is 44. I also know the square root of 4 is 2. 11 is going to be the leftover there, going to go in the second radical. X cubed, that's the same as x squared times x. And we know the square root of x squared is x. This x here is going to be my leftover. In the denominator, okay, I know the square root of 9 is 3, and I know the square root of y squared is y. So we actually don't need to split that. We can, we can get a whole number answer there from what we see in the denominator. Okay, there's not going to be any leftover radical form there in the denominator. 2x times the square root of 11x divided by 3y, that'd be my answer in that one. Part G, okay, again, I'm going to split this into two radicals and then split it again into groups that I know, things that I know the cubed root of and then the leftover. I already know the cubed root of 64, right? So that 64 can go in the first radical. And now some students might make this mistake. They might say, well, 8 times 8 is 64, right? We know the cubed root of 8 is 2. Well, the leftover part is going to be things that you don't know the cubed root of. You see, I wouldn't want to use 8 and 8 because I know the cubed root of 8. And if I stick an 8 here, I know the cubed root of 8, right? So I don't have something arranged in such a way so that I have, over here, I know the cubed root of this number, but in the second group, it's supposed to be the leftover there. Okay. N to the 4, that's the same as n cubed times n. In the denominator, actually, we know the cubed root of 27, that's 3, and the cubed root of m cubed is m. So we don't need to split that. The radical is going to go away completely there in the denominator. 4n times the cubed root of n divided by 3m, that'd be my answer. Here's a definition. Okay, two radicals are called like radicals if they have the same index and same radicand. We can add and subtract radical expressions by combining like radicals, similar to the way that we combine like terms. We just add or subtract the coefficients in front of the radicals. So like if I had 6x plus 4x, that would be 10x, right? Well, 6 root 7 plus 4 root 7, those are like radicals, and so I can combine them like I would be adding, 6x and 4x. 10 times root 7, that'd be my my answer when I add those together. Okay, so let's take a look at some more simplifying here. In part A, okay, it looks like the first and the fourth terms are like radicals. 12 root 13 minus 6 root 13, that'd be 6 root 13. The second and the third terms are also like radicals. Root 3 plus root 3 would be 2 root 3. Okay, now these two are not like radicals, so what I have here is now in simplified form. I can't combine anything else. Now, when it comes to adding radicals or subtracting, you got to make sure that you have like radicals. If you don't have like radicals, you cannot add them. Okay, like what I said here, I cannot add these together because these are not like radicals. Like this is as simplified as I can get it. Let's take a look at part B, the square root of 12 plus the square root of 3. Well, those are not in like radical form, but the idea is maybe we can rewrite one or both of these so that they are like radicals. Okay. So let's go ahead and break down the square root of 12. 4 times 3 is 12, right? And we know the square root of 4 is 2. So the square root of 12, that's the same as 2 times the square root of 3 when you simplify. I've still got this other root 3 that I'm adding, but now I've got like radicals. 2 root 3 plus root 3 would be 3 root 3. Okay. Part C, the square root of 8 plus the square root of 18. Well, I don't have any, these are not in like radical form, but maybe I can rewrite both of them so that they are in like radical form, and that way I can add. 8 is the same as 4 times 2. And I know the square root of 4 is 2. So the square root of 8, that would be the same as 2 root 2. 18, that's the same as 9 times 2. And I know the square root of 9 is 3. So the square root of 18, that'd be the same as 3 root 2. Again, you're arranging things that you know the square root of and then the leftover. Now I have like radicals. 2 root 2 plus 3 root 2, that's 5 root 2, which is the answer. Okay. Now, a mistake that I will see students make, be careful with this, is like they just flat out ignore the square root or the radical in general. Okay. They'll say the square root of 12 plus the square root of 3 is the square root of 15. I don't know what they're thinking when they do that, because that is always going to be a wrong answer. Okay. You don't have like radicals, and so you can't just add the numbers underneath the radical. Okay. I wouldn't get the square root of 26 here with this. Okay. It's not even close. That's why it's important to know how to simplify an individual radical and then try to get like radicals. Let's go to part D. Okay, I don't have any like radicals here. I got to rewrite them to try to get into like radical form. I know that 9 times 5 is 45, and I also know the square root of 9 is 3. So 3 times the square root of 5, that would be the simplified form of the square root of 45. Now the fact that I got a root 5 here in this first term should tell me that a strategy would be to try to get another root 5 on these other two terms, okay? Because I'm trying to get like radicals. Now, it might not happen, but that's something that should be at least floating around in the back of my mind, like maybe there's going to be a root 5 involved in these other two. Well, in the case of 80, okay, 16 times 5 is 80, and we know the square root of 16 is 4. So 4 times the square root of 5, that would be the simplified form of the square root of 80. With 20, okay, 4 times 5 is 20, and we know the square root of 4 is 2. So the square root of 20, that'd be the same as 2 times the square root of 5. All three of these are now in like radical form, so now I can subtract them. 3 root 5 minus 4 root 5 is negative root 5. Minus 2 root 5, that'd be negative 3 root 5. That'd be the answer. Okay, here's another one, part E. Let's simplify these. Now the square root of 18, we've already simplified that from earlier. That was the same as 3 root 2. Okay. With the square root of 32, okay, if we use 16 and 2, we know the square root of 16 is 4, so 4 root 2, that would be the simplified form of the square root of 32. And then with the square root of 98, 49 times 2 is 98, and we know the square root of 49 is 7. So 7 root 2, that would be the simplified form of the square root of 98. All three of these are like radicals because they all have a root 2 part in it. So now we can combine them. 3 root 2 minus 4 root 2, that's negative root 2, plus 7 root 2, that'd be 6 root 2, which is the answer. Okay, here's another one. Let's simplify this. 3 times the cube root of 3, that's not going to break down any further. So let's try to break down these other two here. In the case of, okay, the 5 I'm just going to leave alone. Okay, just look at the cube root of 24. 8 times 3 is 24, right? And we know the cube root of 8 is 2. So 2 times the cube root of 3, that would be the simplified form of the cube root of 24. Minus 8, I'll just leave the minus 8 there alone, times the cube root of 192. Well, now I've already got a cube root of 3 in these other two, so maybe I should at least be thinking maybe I'm going to do something with a cube root of 3 so that I can get all three of these radicals to be like radicals. Well, if you were to take, let's see here, 64 times 3 is 192. The cube root of 64 is 4. So 4 times the cube root of 3, that would be the simplified form of the cube root of 192. All right, now the first term I've left as is here, and I haven't done anything with that. Minus 5 times 2 is 10, so it'll be a minus 10 times the cube root of 3. And then minus 8 times 4 is 32, so it'll be a minus 32 times the cube root of 3. Now I've got all three of these to be like radical form, and I can combine them. It's going to be negative 39 times the cube root of 3 when you combine those. Okay, problem 20. We're doing some more simplifying, only, they've mixed in a variable. We didn't have anything with variables up here. But the plan is going to be the same. Try to get like radicals so that you can add them or subtract them or whatever, So let's take a look at part A. I don't have like radicals, okay, because I don't have the same radicand. One has a 50x squared y, one has a 128x squared y. So let's go ahead and simplify these two radicals individually. 50, that's same as 25 times 2, and we know the square root of 25 is 5. 2 is going to be the leftover. X squared, well, we know the square root of x squared is x, right? Y, that'll be just part of the leftover there. We're going to go right next to 2. The square root of 25x squared, that's 5x. Okay, plus 128, that's the same as 64 times 2, and we know the square root of 64 is 8. We know the square root of x squared is x, so the x squared is going to go on the first part there. The square root of 2y, that'd be my leftover. Okay, and so now I've got like radicals. I can add these together. 13x times the square root of 2y, that'd be my answer. Okay, part B is the last one here in this section. So again, I'll have to, split up both of these and try to get like radicals. In the case of 81, I'm working with a cube root, right? So I should be thinking of 1, 8, 27, 64. Well, 27 times 3 is 81. And I know the cube root of 27 is 3. X to the 4th, that's same as x cubed times x, and I know the cube root of x cubed is x. The cube root of 3x, that'd be the leftover there. Okay, and the cube root of 27x cubed, that'd be 3x. And then minus x, I'll just keep that as is, times the cube root of 24x. Well, 24 is the same as 8 times 3. And I know the cube root of 8 is 2. The cube root of 3x, that'd be my leftover. Okay, and now I've got like radicals here. 3x times the cubed root of 3x minus 2x times the cubed root of 3x. That would be x times the cubed root of 3x, which is the answer. Okay, so now what I'm doing here is exactly the same as what I'm doing over here. I'm trying to get like radicals. It's just, I mixed in the variable. But it's all about organizing things in the group, right? Things that you know the square root of and things that are the leftover. And they're same thing with the cubed root. Okay, things that we know the cubed root of and then the leftover part of that, all right? Be sure that you practice this, okay, the simplifying radicals. The homework is on page 715. And we'll stop right there.